Professor Nur Aisha Sedin Amin, Head of the Chemical Reaction Engineering Group, University Technology Malaysia. Today, I will present our innovation entitled
Eco-friendly biomass-derived nickel cobalt supported modified activated carbon catalyst for hydrogen production. Our product innovation is aligned with the Sustainable Development Goals by the United Nations General Assembly, which is to provide affordable and clean energy, to promote responsible or sustainable consumption, and to take urgent actions to combat climate change for a more sustainable future. The main concept of our eco-friendly biomass-derived catalyst is to utilize two types of waste, namely palm kernel shells and tars. By enhanced catalytic engineering modifications, both wastes are utilized for the production of valuable product of hydrogen, the future energy carrier. Excessive fossil fuels utilization has worse effects on climate change, such as rising sea levels, drought, famine, and extreme weather events. These climatic changes are caused by excessive CO2 emissions with fossil fuels. Thus, we must drastically reduce all CO2 emissions to move towards a zero-carbon society. Fossil fuels associated with CO2 emissions aggravates negatively to the air quality. By using renewable sources of energy, zero CO2 emissions can be achieved. To do this, hydrogen must play a significant role to move towards a greener future. Hydrogen is a promising energy carrier due to its highest energy density compared to conventional fossil fuels. Hydrogen has the ability to power almost everything from cars to trains, homes to industries. Upon combustion, hydrogen reacts with oxygen to produce tremendous amount of energy and only water as byproduct with zero carbon emissions. Hydrogen energy is useful and efficient for mobility or industrial applications, power to mobility such as cars, buses and trains, and its application for the maritime and aviation industries are being developed as well. Power to industries using renewable and clean hydrogen will reduce CO2 emissions and fossil fuels dependency. Cleaner fuel of hydrogen is beneficial towards mitigating climate change, reducing fossil fuel utilizations, and improving air quality. Moving towards a sustainable future, we have developed a low-cost and efficient catalyst for hydrogen production derived from palm kernel shell or PKS material. PKS is the byproduct of the crude palm oil industry. After the collection of fresh fruit bunches from palm plantations, it will be transported to CPO mills to be processed for the CPO extractions, where they are sterilized, threshed, and crushed. PKS are the shell fractions left after the removal of the kernel. The higher amount of CPO, the greater amount of PKS generated. Palm kernel shells waste were either dumped in open fields or rivers or used as the boiler fuels and diesel or charcoal replacement. If PKS waste is piled up at the CPO mills, this creates a dangerous breeding grounds for insects that eventually cause massive damage to the palm plantations. PKS can also self-combust if it is left unattended for a lengthy period. A sustainable and eco-friendly catalyst which utilizes the waste of palm oil industries is beneficial to reduce environmental pollutions and contribute to the growth of our very own sustainable catalyst industry that can create jobs and boost local economy. Our catalyst is specifically developed for the production of hydrogen, the future energy carrier that can help substantially in reducing CO2 emissions. Our innovative invention is one of a kind because it is an eco-friendly and low-cost biomass-derived catalyst which utilizes waste of palm kernel shells as biomass-derived activated carbon catalyst support material. This promotes waste-to-wealth generations for palm oil industry. It has superior catalyst performance for hydrogen productions, and it is specifically designed for high removal of tar waste. Tars is the unavoidable byproduct for renewable hydrogen production via biomass gasifications. Tars causes serious hazards to process equipment of downstream processes and decrease gasification performance because it lowers energy content of desired gas products and conversion efficiencies. It also increases process maintenance costs and causes catalyst deactivations. Besides, tar also poses high toxicity risk to human health due to its carcinogenic properties. Hence, tar removal is important since it hurdles the successful implementations of commercial biomass gasifications for hydrogen productions. Toluene is the major compound in tars, hence toluene is selected for catalytic steam reforming for hydrogen productions. Catalytic steam reforming is the most effective technique to convert tar to hydrogen. High catalytic performance and stability with mechanism of anti-deactivation is highly desired. Here we present our eco-friendly catalyst product, which is a registered patent under the MyIPO, also known as the Intellectual Property Corporation of Malaysia. It is an efficient and sustainable bimetallic nickel cobalt supported on modified palm kernel shell-derived activated carbon catalyst for hydrogen production via steam reforming of toluene as tar model compound. Our product innovation is attractive towards sustainable waste management of both PKS and TARs for the production of valuable hydrogen product. The synergetic effect of the catalyst modification and optimum metal composition yielded high hydrogen products with extended stability in the reforming reactions of tar compounds. Now, let's get to know more about special features and characteristics of our eco-friendly catalyst. Our eco-friendly catalyst consists of the modified PKS-derived AC support which obtained using the effective surface modification of PKS AC support by aging oxidation technique. It has high surface oxygenated functional groups and highly microporous structures. This allows high nickel cobalt active metal dispersion on the modified AC support. Hence, successful active metal impregnations with high metal dispersions was achieved as confirmed by the PSEM microscopy and leads to high hydrogen yield and catalytic stability. The technology innovations of our developed catalyst is that it has high catalytic performance and stability out to 325 hours. This is due to the synergetic effect of nickel cobalt and modified AC supports results in high hydrogen yield of 97.7% and toluene conversions of 87.1%. High nickel cobalt dispersion on modified AC also plays an important role towards enhancing the hydrogen yield and tar conversion in steam reforming reactions. The analytical characterizations of BET, FTIR, and Raman spectroscopies has confirmed that the modified AC support possess high microporous structures and high surface oxygenated functional groups. The TEM images of spent catalyst shows that high catalytic resistance was attributed by the anti-deactivation mechanism by carbon nanotube formations and active metal migrations during reactions. The anti-deactivation mechanism of our eco-friendly catalyst promotes water-gas shift reactions and prevents carbon encapsulations of active metal sites during reactions. Here, we illustrate further the postulations of the catalyst anti-deactivation mechanism. After the dissociation of the reactants and adsorption onto the catalyst surface, the carbon atoms dissolves and diffuse in the metal particles with the dissociated water to form the liquid cobalt. Then the graphite layer of hexagonal mesh structures dissolves out the metal particles to realize the growth of carbon nanotubes on the catalyst support. This allows the metal particle to migrate to the tip or on the surface, which enhance the metal dispersions and prolong catalytic stability for hydrogen production. In comparison with other catalysts reported in literatures, our synthesized eco-friendly catalyst performance was superior. Our catalyst invention could contribute to increase the knowledge in palm oil industries to explore opportunities of utilizing the generated waste of palm kernel shell towards catalysis industries, hydrogen productions, and fuel cells technologies. We have prepared an effective commercialization strategy and identified potential industrial partners in Malaysia. Due to the attractiveness of our catalyst product innovation, we have successfully secured collaboration partners to proceed for the product commercialization. Through this product innovation, we also have successfully published 3 research articles in citation index journals. Lastly, thank you for watching. Stay healthy, stay safe.
Hi, I'm Professor Nur Aisyah. Tiba-tiba pula